So I'm using this regression model for this.
Do you think me asking you to detect latitude or find latitude would cause a lot of issues? Hey Bhavai, really nice to meet you. How are you doing?
I'm good, Karthik. How are you?
I'm awesome, to be honest. I'm a bit stressed, but a lot of work. But otherwise, it's great. So I was going through your resume, Bhavai. So it's very interesting. Reason being, first thing, obviously, you have masters in data science and you have bachelors in data analytics. That is rare combination I see, especially in a lot of candidates. And secondly, your entire work experience is also mostly data science, and obviously there is some parts of AI engineering as well, but it's more machine learning and data science. So that's great. So can you briefly explain what did you do till now? How was your bachelor's and master's experience, and how do you think your master's studies have helped in your daily life, work life, or whatever you call it?
I would probably say like my bachelor's was in data analytics and it was great. Because otherwise like we do not think of data analytics and data science. I was unaware of the field of machine learning, what is natural language processing and the deep learning. And after that I got into like the field of generative AI. Like my first internship and my first job was to like very industry specific. It was taking the images or the text from like top industry or top like textile firm, and there are customers who are just sending the screenshot or the text explaining what kind of patterns they want, and
Hmm.
we have to generate those patterns using DALI 3, Midjourney, or GPT-4 model. And it was like one of the best experience like I have, because we are into the industry and we're solving the real problem from the customer. And after that, again, like shifted to a big company, working as a data scientist, working on those pipelines, production ready pipelines. Again, great experience. And my master's, wow, man, that was like doing it with the job. uh yeah, it
I
was
know.
very.
I know it would be very hectic first, but I would assume it's very interesting as well, right? Uh, because I did my master's as well as an executive degree. So it was a lot of work, day and night. Today you are going to work and at night you're going to prepare, right? So, but I assume it gave something to you, right? At the end of the day, that you learned a lot and it's helping you in your daily work life. I mean, I'm assuming that. Um, Other than that, so your interview, right? So first 40 minutes, it's gonna be basically the technical round. We are gonna discuss few questions and how would you arrive at the answers and all those things. And later we are gonna have a review session where we are gonna have a back and forth on how did you perform in this interview. Yeah. So
Yeah,
first one
great, man.
is, oh, can you open Google Colab, please,
Yeah, sure.
and share your screen as well. Just connect to some server already. So if you can click connect on the top right. So, I mean, the default runtime is fine. We are not going to do something too intensive. So, if you can go to folders, if you go come down slightly, there is a folder symbol, right? Yeah. Go to sample data. Okay, so there is a data set here. It's called California Housing Dataset. It has train as well as test. First, I want to see you exploring this data set. Okay. And tell me what are the interesting things that you are finding and what do you think interesting about this data set. Are there any issues with this data set? Then we are going to go to the modeling part. Okay. And then we are going to build some kind of useful model which is going to predict few things. So make it a back and forth discussion. So whatever you're thinking, just tell it outside. Okay. So I will also interrupt you in between if I seem something is interesting as well. Yeah.
Okay, good.
And also, don't hesitate to use AI for syntax, not for logic, obviously, but syntax. If you need some help, do take help of AI as well. Yeah.
Okay, great. So I'm gonna just import basic libraries from here: pandas, sklearn. uh, then I have. So this is our basic data set that we have with us. Uh, Now we could actually. in this data frame, I need to check the info of this, like how it is. So we have this, all the items in the float. Okay, good. Now I just want to check like how many items are there in the null, right? Like they are null and void, and these are not. So I would actually go ahead and do this. Okay, no items is null. Again, great. Now I will just see if it is describes it. Okay. So here we got this median of it, mean, max, count, and everything. Now we can just from sklearn we can import
So
our
before
data
we go into
split.
anything more, right? Can you briefly explain me what is the properties of this data set? Do you see something concerning, or what do you think about this data currently?
Yeah. So if I just okay. So if I deeply think about this data, okay. So I have total count, mean, standard deviation, minimum, and okay. Just give me a moment.
No
I'm
worries,
very
take your time. Yeah.
okay. So count tells me the number of non-null values, which I think all is same, which means like there are no null values in there. Then I have mean, which is average of those values. I have got those averages for each of these. And then I have those standard deviation, which is the spread of the mean, like how it is deviating from the mean, which I have got. 25% is the first quartile, how it is performing in that. 50% you could say like it's the median of like each of these columns in there, and the third quartile, and then we have the max of each of these columns. So for the longitude and latitude, for the latitude, you could easily say it is for a geographical location,
Mm.
and we could see like this. It tells us 119 degrees and 35 degrees. It talks about a specific location which we are seeing our house for, and it talks about like the population and the median income related to that particular house in that. And like so as just an observation for this particular data set is that these coordinates are very widespread, which means that this house actually comes from multiple areas because we have different longitudes and latitudes. And the average age of the house we could see here, which is here. So you could see like these are 28 years, 12 years, 1 year. We could see the average age of the house.
Okay, so let
And
me ask questions. Okay, so first one is, which feature has more outliers currently with the help of this particular describe table, right? Can you find which feature has outliers or significant number of outliers? So first question is, can you find it using this data? That is the first question. If yes, tell me which particular feature has. If no, tell me why you cannot find it. Yeah.
okay, so first I can find some of the outliers. Like if I see it, it just blurt, blatantly like comes out like which is total number of rooms
Mhm.
in a household, and there are like 2600 rooms in a household, which are for me it is an outlier. Total number of bedrooms and like the population for this and the households.
So for example, let's talk about total bedrooms, right? So
Yeah,
minimum bedrooms is 2,
yeah,
right? And maximum bedrooms is how many? 5419, right?
yeah.
So why do you think there would be 5419 bedrooms? What could you infer from this?
I could probably think like this would be a very dense populated household, like it has a very big hotel chain maybe, or like many like a chawl kind of a scenario. Maybe it could be there, like uh,
So basically, one thing you could obviously infer is it's not only talking about small houses, right? Or
yeah.
family houses. For sure, there is something else. Either it could be hotels or it could be community housing where there are, multiple houses which are stacked together. There may be apartments. So that is one thing I can infer. Coming to population, what do you think this population is related to? Is that the number of people living in that house, or what is it?
I think it is the number of people which are related, which are in the like nearby area or like living in that near household area, or like represents the total number of like people living in a housing block, or that particular pin code or that longitude and latitude pinpoint I could incur from this lake, because these like 4,930 people cannot live in one single particular household. So it is just a location of that particular pin.
So these are some interesting things, right? You can get 1,000 questions. Now, one more question I'm getting is the median income. Okay.
Yeah.
So if you see the min, it's 0.4999, whatever it is, right? And what if you see the max, it's 15. So what do you think this particular income is? Is it in rupees? What is it? What is the unit? What could be the unit for this?
I don't think so. It is in rupees. I think it would be in a USD dollars.
So is it just dollars? So you are saying min is $0.499?
I don't think so. Like this could be in a like $1,000, like or $10,000. Like it could be like 3.5 into 10,000, which means like $3,500. So they have just used the standardized format for this, like write in 3.5 or 1 or 15 in there.
Good. Yeah, makes sense. Next question is, are there any categorical variables in this?
Categorical variables.
Or you can say categorical columns. So do you think any of the feature is a category?
Categories. I would probably say like there are very numerical variables in there, and it does not have a very strong categorical features like gender or a city type or a product category in there. But you could probably say like these are all the very numerical specific. If you talk about longitude,
So you're saying
latitude,
it's continuous variables, right? Is that what you're talking?
yeah, it is all continuous.
Good. Cool. I mean, I got few doubts clarified now. So let's go to the next one. So what would be your next step?
I would like use a train test split and would actually create a training test split, because I know like this data is quite organized, and this is not the data we get actually in the real life.
Mhm.
Uh, but yeah, can tell me like if you want to do any data analysis on this or build some graphs.
So
Interesting.
I want to just do some initially at least some exploratory data analysis. What do you think would be good? Basically, I don't have any restrictions here that you need to do this. So can you do some kind of exploratory data analysis on this, and then we can have back and forth.
Yeah, definitely. So first, I would just tell you like what is EDA. So EDA is basically like we understand the data distribution, identify the outliers, detect the skewness of the data, like if it is like right skewed, left skewed, or it is equally skewed, and then we analyze the feature relationships, find all the missing values, which I didn't find it any, but in real life you will actually find a very different data, and prepare this data for ML modeling in there. Uh, Now we have done actually like we have no missing values in there. We have got the data types in there, and we could just find out the df dot shape of this to find the whole picture. Not this. Yeah. So you could see like there are 3,000 rows and 9 columns which are in there. And now we got the missing values. We have got the statistical analysis using this df.describe, and I could actually put my distribution analysis using a histogram.
Mhm.
I think I have used this before. So let's try to get it. And I would probably say fixed size in there, and fixed size equals to 12 comma 10. And this is probably it just shows us like how how the population is heavily skewed, and what are the total number of income total rooms which are heavily again skewed, and the
Mhm.
medium income, which you could probably say it is quite normal in there.
So let's talk about longitude and latitude. So what do you think is so special about them?
I would probably say that these are these are very skewed on the basis of like it is very distributed. Like these are not skewed on a left skewed or a right skewed. These are distributed on the basis of like it has a pinpoint of 600 comma this
I mean,
latitude 12.
I don't know what is distributed means. Uh, I mean, can you tell me something more technical? So, because you did a lot of data science related work, right, and you have masters as
Yeah,
well. What are these distributions called? The longitude and latitude.
yeah, definitely.
So, can I call those maybe bimodal distributions?
Okay, just let me think about this. I think it is actually called as it could be like a bimodal. Yeah, I think you are correct in this.
So if I say it's a bimodal distribution, what do I mean basically?
Bimodal distribution. So I think it is like a very specific in this data, like when we have like the core idea behind this bimodal distribution is that it has like two different peaks in there, and you are correct, like in the longitude and latitude have two different peaks, and one peak you could say like in a specific area and another peak in a specific area, and which means that it has two specific clusters of those locations, and we could probably see this. So in a normal distribution, any data science student would tell you like there is like a in a Gaussian distribution or normal distribution, there is just a one peak that we have. But in the pi model distribution, we have actually two peaks, which means we have two local maxima in there. And the only thing that I can infer from this data set is that it has two populations which are heavily densed and heavily skewing this data to two population or two regions and or two customer groups, you could say, which shows us two different behavioral pattern for this data set.
Good. So that's good. So can you tell me what kind of skew that bedrooms have?
You're talking about total number of bedrooms, right?
Yeah.
uh, you could say like it is it we talked about like pi model, and there is actually a peak called like norm, like it has only one peak in there, which
So
means
is it
like it
left
is
skewed or like right skewed? That's what I meant.
like it is like left skewed, like because it is just showing one peak in there, and we could see like we have fewer bedrooms on the right hand side, but on the left hand side it has a peak, which is like large bedroom counts in there and very dense apartment areas and urban housing complexes in there.
So for example, okay, forget about what you just said now. If I want to calculate skewness of a data, how would I calculate? Do you know how to calculate it or what is the methodology to calculate it?
Yeah.
Yeah. So let's start from there. How would you calculate, for example, skewness of total bedrooms?
Yeah, so like if I just talk about like the total skewness of like a data, it would be asymmetry in a data distribution. We could see a left skewness, right skewness, or a bimodal or a normal distribution. It tells us whether data is symmetric, as you mentioned, or left skewed or right skewed. And you could see like a symmetric distribution. It has like a it doesn't have any skewness, and like uh, a positive skew, you could say like it has a long tail on the right hand side, which I see on the bedrooms, which talks about like the mean is actually greater than the median, and it could be like our total number of bedrooms, our income also shows the same, and our population also shows the same kind of positive skewness. Then there is a negative skewness, which actually has a very long tail on the left hand side, which actually means that median is very much greater than the mean, and we could find this skewness in Python, and yeah.
Cool. That's okay. So let's move forward that. Okay. So or past that. If I have skewed data, okay, and we have kurtosis as well. I think you might have heard kurtosis, right? So what would be difference between skewness and kurtosis? That is the first one. And once that is done, if the data is skewed, what would be the implications? For example, if you're talking about this particular data set, what would happen if a data is skewed? That would be the second question I want you to answer. So yeah, let's start.
Yeah. So you talked about like our skewed data and the kurtosis, and what would be the impact if it is skewed, right?
Mhm.
So I would just tell you like the first skewness is the asymmetry of distribution we have talked about. We have positive, we have negative, and we talked about like what are the different impact of the skewed data, which means like there is a distort mean, there is a, violation of normality assumptions that we usually do in a normal or a Gaussian distribution. It affects our linear regression model, and it actually impacts the KNN or the SVM model that we have. But we can actually handle these skewness using long transformation or
So
proper.
why would skewness impact SVM model? I'm very interested to, you to explain that.
It would actually impact the distance calculations if we have.
So for example, I have skewness in my data. So why would it impact my distance calculations?
Yeah, so if there is a skewness, which means like that there is a positive or a negative, it would actually impact the both for the those supervised learning model, because these are actually models are sensitive to feature scaling, data distribution, and the outliers, and these are all the distance related. And if it is
So the
skewed.
problem is this, right? Okay, well, let's start the discussion here. If there is huge skewness, whatever you call it, and there is huge standard deviation, which do you think would affect SVM more in this case?
So if I would think like if it is a like skewness and standard deviation are both different, and deviation is actually calculates the spread from the mean, and skewness is just talks about like data is tilted towards left, right, or asymmetric. I would probably say like standard deviation would actually if it is highly variable, it could give us a very biased skew outlier in that manner.
Okay, so let's move forward. Okay, cool. We have did enough analysis from this histogram. Let's move forward. So let's do further exploratory data analysis. What would you do next?
Next, I would like to build one more. I think bar plot, box plot. I think. Let's think of what we can build. We can build our correlation analysis. What do you think? Or do you want to start with the outlier detection first?
Let's start with outlier detection and then we can go back to correlation.
We could use our Seaborn library, and we would actually import our matplot. And we have data equals to df, because we have stored in a data frame as called a df. And then we have our x tiles in there, which is x takes, and we will do a rotation on 90 degrees. Okay, then we would just write plt.flow to show the we have did. So we are doing this box plot for this, and in here uh we could we could see like the highest outlier in there, which is total number of rooms, population a bit.
I mean, others are not even visible, right, above.
Yeah, the main is like median, would say.
So how would we fix this plot then to make sure everything is visible?
Yeah, I would probably have to change the size of it. Okay, that's the only variable we have in here. Let's try with 12 and 6, because we did it. And I think we have to like scale the data set for it.
Okay, so let's do that. Let's see how it looks like.
Okay, let's do and see like if it is shows our data set if we do a standard scaler in there.
So before we do this, right? So what kind of scalars we can, or to scale the data set, what are the choices we have? Let us discuss maybe one or two choices and discuss pros and cons with those.
Yeah, so there are like different methods through which we can actually scale the data. First one is the our standard scaling, which we mostly do, which is uh, uh, you could say like normal distributed data it has, and it helps us to scale the data. Then we have a min-max scaler, which is most commonly used for any neural networks or a bounded values, which we have. Then I think we also have a robust scaler, which is very outlier heavy data.
Mhm.
And then we could also use a normalizer, which is used for any text or vector uh, scalability.
Mhm. So what if I do min-max scalar for this? This particular data set, if I do min-max scalar, what would happen? Is it good choice or do we face some issues?
I think the why I'm not doing a min-max scaler in here, because it actually stores the values in zeros and one. which is not actually important in here because it will not show, because we have like very higher values in here, and those like min-max scalar for zeros and ones are actually helpful for any deep learning, image processing, or any bounded feature systems that we build. And it is very highly sensitive to any outliers, so I would probably not use this in this scenario.
Okay, so let's move forward.
Yeah, so let's do a standard scaler in here. I think it has to be first. I think I have to import this. Okay. So I have to import this standard scalar library from the sklearn first. Then I can use this library in here. So I'm just importing this. Import standard scalar. Yes. Now I can use this library. Here it comes. I have done it. Now just scale the data in here, and I want scalar dot bit transform this data, and which is our data frame which we have given the input for. And then I think we could have our scaled df, which is our pandas dot data frame, and we could have our scaled data which we earlier did using this. And actually we could have our columns as df dot columns in here. Let's try this. Still it just shows the same.
I mean, you haven't changed it, right? For the box
uh,
plot. Can you check what you're sending?
oh, okay. Yes, yes, you are correct. Correct. Scale df. Now it shows.
Okay, that's awesome. Now, if you think about it, which feature has, more outliers?
Uh, we could clearly see like the total number of rooms have the most outliers in there, and but then we have total number of households, bedrooms, population. Uh, these all have very high number of outliers, and then we also have a median income and median house value. We have somewhat a less outliers in there.
Okay,
So
so
we could
I
see,
mean, we cannot get absolute count from this, right? Obviously, if you say it, there are certain tails which you can observe, but obviously there is a very thick region where there might be multiple outliers. So if I want to exactly answer the question where I want to know which particular feature has more number of outliers, how would I calculate it?
yeah. So we could do this. I think. Okay. I could do this. We have to actually build this whole box plot in this mathematical uh, formulae, and we have to calculate this Q1, Q3, and the outlier. Uh, okay, so we could do this, and we could have a total outlier as a 0 right now, and then for column in df dot columns, we could have our Q1 as df dot quantile 0.5 0.25, which means it has only 25% of the data.
Mm.
Then we have this q3, which has actually the 75% of the data in there, and we could just write this. And then we have our iqr, which is our interquartile range, which is measured by dividing subtracting q1 from this q3.
Mhm.
And yes, we could have our lower bound after that. Lower bound, which is actually calculated using Q1 minus the 1.5 of our IQR.
So why do you think it's, I mean, why are you taking 1.5? Can I take 2?
No, actually, like it is like 1. I think it is like mostly it is like 1.5, and it is like a mathematical formula behind this because one it
So have you
actually
been ever curious like why there is 1.5? I mean, it's just a curious question from my side. Why is 1.5 so special that it is there? Do you know why it is there? It's fine if you don't know. No worries.
if I just think about this like very like specifically, then I think like I have thought about this like why it is there. Like I think there was a rule and in most of the like stats or maths, they like there is always a rule which talks about like this is the formula and you have to stick by it. But I think why it works well, because it actually helps us detect the extreme values and find out like avoiding any excessive false outlier detection in there. And 1.5 into IQR, it actually like helps us find the acceptable spread behind those quartile ranges which we are working in, which is Q1, Q2, or Q3. And yeah, it just would help us like find the
I mean, I
like
would
a very
give you a
statistical
clue.
threshold.
Sorry to interrupt, but I can
Yeah.
give you a clue. Okay, so for example, clue is this. If you do all these calculations for a standard normal distribution, that is where this relation is coming from.
Okay. So if I do all the calculation in normal distribution. Oh, okay. Maybe it is like a cutoff range for our outliers in the IQR, and it is like there could be like a one which is which could be like very aggressive detection, but 1.5 would be a standard balanced detection because uh okay.
No worries. Let's move forward. And we can stop this outlier part here. Okay. At least I got clarity that you know how to create, count the number of outliers. That's perfect. So let's actually go to the modeling part. Okay.
Okay.
Now my goal is to use as many features as I want. Okay. Normally, this particular data set you generally use to find, for example, median house value, right? This is actually called housing data set. And based on all these features, you will try to find house values. Okay. But today I'm thinking slightly differently. What if we use all the features and try to detect latitude and longitude? Let's select maybe only longitude. Okay. So your goal is to use all the features and detect latitude, and we want to achieve as much accuracy as possible. So if it's above 90, I'm very happy. If it's below 90 is also, I'm fine. So let's start the modeling process. So what model would you use to detect latitude, for example?
Okay. We could use any like a supervised model in there. I think like most used is like random forest regressor, because it would help us like find all the non-linear relationships and the skewed data it has, and it is actually helpful in like number of outliers and all the geographical patterns in there. So it
So
would
why
actually,
not boosting? Why are we going for the other model you have mentioned?
yeah, we could also go for a XG boost. It is actually a very strong model, and it would actually perform very better in this. Uh,
So if I take, for example, random forest versus XGBoost, for example, so
okay.
what model would you think would give very good accuracy for this question, basically?
I would probably say like XGBoost is going to give the best output for this. Uh, but why I'm getting for the random forest, because it would help me build very independent decision trees, and each tree would be like a random subset of those data and those features, and we could actually get the final prediction on averaging or the classification in there. And the like the basic advantages, if I just blurt out for the random forest, is that it is very simple, stable to use. It is very robust to our outliers, and very less tuning is required while we build the random forest. And it just have a very baseline model, and it handles all the missing or the nonlinear data as well. But on the other hand, if I just talk about the XG boost, it is a very great model to build for this particular data set. It builds trees sequentially one after the other, and it actually learns from those errors which are made by the previous trees. It minimizes all the residual loss iteratively. And the key idea behind using this XG boost is reducing the bias in the training data set and improving the prediction accuracy. But why, the only disadvantages that I would probably tell you about XGBoost and why I would not use it, because it would require more and more parameter tuning right now, and it is very sensitive to all the noise and the outliers we have right now, and it can actually overfit if not tuned properly in
For
this.
example, what if we remove our outliers? Then would your decision change?
um, then I think still I would actually use XG random forest, but it would actually require a lot of hyperparameter tuning for this. And
Okay, so let's do one thing, Bhavai. So let's build it using random forest itself. Let's see how accurate would you get.
okay, great. Let's build this.
So luckily we do have a test data set in the same folder. Okay.
Okay,
So we are going to actually use it. And I mean, let's make it fun. If you don't get above 90, then I'm very sad. Okay. So, so let's make your interview pass or fail based on if you're getting above 90 or not. Okay.
sure. Let's first import this. So I'm using this regression model for this because we are going to find the relation between them. And I would actually use this model as random. Okay, let's now build this our. We have training data set right in here. Let's build it for it. Okay, let's see. Could have our X.
So before you build it, right? So do you think me asking you to detect latitude or find latitude would cause a lot of issues for you?
Yeah, it would.
So why do you think so?
I think in there it would actually makes a lot of sense if I drop the latitude in there, because is not latitude is not actually dependent on very features. Uh, Basis on like any population or the mean, uh,
So
which means that
basically, I mean, it's very simple, right? If you think about it, uh, I can say, for example, people with less income generally stay in this area. Okay.
yeah,
And it's very tough to say in the entire latitude. Basically, latitude is a, it's not even specific point, right? If you combine latitude and longitude, you get location. Now, only latitude doesn't even give you single location. It's a possibilities of location. Would you not think it causes a lot of issues? I mean, I assumed you would ask this question initially itself. That's why I said if I'll fail the interview if you don't get to 90%. So, do you think you can get to 90% for with finding latitudes?
I don't think so. Like it would makes a lot of sense. Now, if I like go into like an interview mode and see the problem clearly, because it doesn't have any relationship. Yeah, you are talking correctly. Like there is a non-linear geographical relationship with it, and there is a very high heavy dependency on longitude plus latitude, and we would need actually the spatial clustering for it. And yeah, there would be a very outliers and skewness, and due to this weak correlation for this features, it would actually go down to like not even like 50%, I would say.
Cool. So that's it from my side, Bhavai. So we are done with our technical round. Let's go back to actual discussions. What I found with this interview, and I want to hear your viewpoints as well. Okay.
Yeah,
So I would say the pros, I mean, of this interview from your side is you have really good working knowledge. Whenever you are creating histograms or writing some kind of code, right? It proves that you have worked on this multiple times before. It's not like you have by hearted something or whatever it is. You know what to write, how to improve the figure sizes and all those things. So it gives you much more comfort, right? Whenever you are performing in the interviews, interviewer, you don't need to again go back to ChatGPT or website and check syntax and come back. So that is one thing. And also it also proves quite a lot of working knowledge you have. So that is first thing. And you know why certain things the work that way, especially the statistics part of the data science, right? To be honest, data science is nothing but statistics at the end of the day, if you think about it. So you have good understanding of why you are doing certain things. For example, why you are plotting histograms, right? Or why do you need box plots? But the problem I've seen is you are like slightly doubtful on what actually kurtosis and you know skewness, what actually they mean. You know what the definitions are, but at the end of the day, if you're talking about for second moment, third moment, right, from the calculation perspective, you could have gone into much more in depth. That's what honestly I felt. And secondly, one negative, I mean, overall in the interview, one negative I did observe is you are, whenever I ask so very specific questions, you generally answer not too specifically, it tends to go around some kind of experimental paths. So the answer is slightly getting towards generic. It's not always, but in a lot of questions I did observe it. Okay. For example, if I asked why do you use random forest versus XGBoost, you don't need to understand or explain me how XGBoost works, how random forest works. It's just the differences, right? That is more than enough to answer this question. And also, that is the obviously one con with this particular point. But your knowledge level is very good. I mean, I love the way you answered questions, as well as the model creation part, right? You immediately went to random forest and XGBoost, and that would what I would go to towards as well, because those two models really perform well, especially for this kind of use case. But this kind of shows one weakness, which you can easily improve, which is you need to think from the business perspective. So if I am asking you to predict something, immediately your mind is going towards the technical aspects of it, right? But think, why would someone ask you latitude? What would be the issues of finding out, or at least finding latitude from the model development perspective, right? So that is one thing, which is business use case. And secondly, you should have guessed that latitude and longitude are very much related to each other to find the position which is actually related to all these kind of features, right? And getting income from these features is very different from getting location from the other features. So even from the business perspective as well as the technical perspective, right? So that you can obviously improve. It's nothing you are, because you are very technical about this. That's what your positive feedback was. So you are moving towards technical first, then actually understanding, what is the requirement and why do we need to do this and what would cause issues for this particular problem, right? Other than that, I would say this is a very good interview. You did well, for sure. Obviously, if you can improve these 2 points, I'm pretty sure you're going to go and crack very, very tough interviews as well.